Howdy, folks. So today I'm going to give a talk on cautionary tales in UI testing. This talk is recorded, so it'll be available for viewing in, I think, a week or two. It just depends on when Codementor does the editing and everything. I asked everybody what their role is, and I see a lot of quality engineers. That's great to see. QA leads, some front-end devs. Always enjoy the front-end devs. This is actually going to be a talk. I myself am a front-end dev. I shouldn't get into my presentation just yet, but this will be focused coming from a front end perspective. Yeah. So let's get the presentation rolling. If you have questions, if you want to type them in the chat, that's fine. I don't plan on answering them until the very end. I'm going to try and ignore the chat, honestly, until the very end, because I want to make sure that I keep moving forward, because it's going to be a lot of information to go through today. But let's get started. I am Kevin Lamping. This is a recent photo of me from a backyard cookout I had this past weekend. This unicorn hat is my daughter's, but I'm trying to steal it away from her. She's not letting me take it away from her. So I'm still working on that. I am a front-end engineer and a tester. So I've been doing front-end engineering since high school, which was a long time ago. Graduated college in 2006, started working on websites for a design agency, been doing drop downs, accessible drop downs since then. That was one of the first big JavaScript things I did, was implementing an accessible drop down. I was actually using, I don't know if y'all remember back then, if you front-end devs remember this tool called Superfish. It was this accessible drop down. It was really cool. You could use your keyboard to navigate it. I'm part of the technical steering committee of WebDriver IO, which is a automated testing framework that uses WebDriver bindings and Selenium, kind of Selenium. It's technically WebDriver, but a lot of people would refer to it as Selenium. So a member of that team. I've been working in test automation for about 8 years. So I made a transition about 8 years ago from focusing specifically on front-end development to more on how do you test the front end using automated testing. And I've been helping teams kind of build and integrate their UI testing framework and their testing suites into their development process. And that's where this talk comes from. It's just working on all of those projects and kind of the lessons I've learned and the ways I've been burned by it along the way. So a quick caveat on all of this. When I talk about testing, I'm just going to say testing for short. I mean automated UI testing. I'm not specifically talking about I'm not talking about unit testing or performance testing. Those are very valid and very good things. But this experience is all about UI testing, and specifically automated UI testing. You could also call it browser testing, functional testing, end-to-end testing. The nomenclature, the naming of it, it doesn't really matter in my mind. What we're talking about is teaching a computer to use a website and validate that that website works. So with that caveat, let's go ahead and get going. So why do we test? Because testing takes extra work and it takes a lot of time. So what's the point? Well, ideally, the point is to make sure things work. You want to test it to make sure it works. If you don't actually test it, how do you know that it works? And well, that's what happens when we don't test enough. Spaceships burn up. For example, this spaceship burnt up, or they're actually not sure what happened to it. It either burnt up in the atmosphere of Mars. This is Mars Climate Orbiter. It either burnt up in the atmosphere or bounced off the atmosphere and is in a sun-focused orbit. Something happened. I would poll the audience, but I don't want to wait for answers through chat if you know why this spaceship burnt up. But it basically came down to NASA was using the metric system for distances, and one of their contractors was using imperial, so feet, miles, that. And this discrepancy between those two units, they didn't realize it, caused this spaceship to get way too close to Mars, like within 35 miles of the surface, I think. And that's not good when you're not supposed to be that close. And to quote from an article I read, officials at NASA said that they failed to make the appropriate checks and tests that would have caught the discrepancy. So there you go. We didn't test enough, and a spaceship was lost. A very important, very huge project was lost because of it. That's not the only spaceship that's had trouble because of testing. How about Boeing's Starliner? That's not the full rocket. That's just the very top of the rocket. This new capsule that's supposed to take humans to space. So it's had a lot of issues if you follow any space rocketry stuff. But basically, to quote from another article, what happened with this Starliner is they launched it as a test run. Thankfully, it was a test run. So they were doing testing. They're just testing in production. Thankfully, not with humans on board, because what happened was there was a timing issue. So the clock on the computer that runs the capsule and runs all the electronics was not set to the right time. And so that clock was important because it needed to be set to certain launch times and everything. And it was supposed to get up to the International Space Station, except that it ended up firing its rockets too early, I think, and ran out of fuel to get up there. And it was also, along with that, there was a couple other issues that caused it to potentially burn up in the atmosphere, which is not something you want it to do if it had humans on board. And to quote from this article, Boeing engineers performed testing of Starliner software in chunks, with each test focused on a specific segment of the mission. They did not perform an end-to-end test of the entire software suite. Doesn't that sound very familiar to like just websites in general? Is this idea of we test everything in isolation, but we forget to test the whole thing all together. And I think this just highlights that this is a difficult problem. Testing is a very difficult problem. And this is what I'm going to be talking about today. The question is, why don't we test more? It's pretty simple to me. It takes a lot of time, and we don't necessarily have that time, especially when software gets delayed and then, you know, the testing parts get really shrunk down. The time allowed for testing gets really time crunched. And then it's also, we're ignorant on what needs to be tested. We're always testing what we think needs to be tested, but it's tough to know everything. It's tough to know specifically, when you combine this component with this component, it's going to break. Or this third-party script that's supposed to just be plug and play actually completely destroys this other utility that we have. And then finally, it's hard to test, especially in the browser. It's hard to get the environment set up in the specific way you want to get it set up in order for the test to work. So these are a few reasons why it's hard to test, but another huge reason why it's hard to test is this function right here. So this function comes from an article called Testing is an Unsolved Problem. I highly recommend it. I will link it in the chat when I get to it at the end. But this is a basic function. So basically, you pass in an integer, you add 1 to that integer, and you return the value. So if the input is 1, then it should return 2. If the input is 41, then it should return 42. 419, it should return 420. But here is the issue, is that software testing is an infinite and unsolved problem. So this is from that article. It's one of the very top, it's in the lead up paragraphs. I don't know what I'm trying to say here. Software testing is an infinite and unsolved problem. You got to really believe that, because if we look at this function again and we think about how do we test this function, well, it's pretty basic. You put in, you call the function with a number, you validate it, that returns 1 more than that number. Well, that works for that number, but what about the next number and the next number? What happens? Like, this is a very simple function, but you can't know for certainty that this function always works for an infinite number of numbers, because you would have to write an infinite number of tests to make sure that it works for all those numbers. And you think, well, that's silly because it's just a basic mathematical operation. But, you know, computers have limitations, and at some point, this function is not going to work on the computer system because it goes out of bounds with the numerical input. So at some point, this function is not going to work just because of the limitations of computers. And so you can't know for certain ever in any of your tests. You're never going to know for certain that something as simple as this function is going to work. So it's just, even for a simple function, it's too large of a problem. So how do we validate that this function always works? The answer is you don't. The answer is that it's impossible. And if something as simple as testing this is impossible to do conclusively, then think about trying to test a website, and then, all the complexities of that. We got to set our sights a little bit lower here. And to quote from the article, it's easy to write a few lines of code, quite another to test it. And I think that is the sum of my talk right there, is that UI testing is very difficult. So let's get back to, why do we test? Well, I said to ensure things work, but that's clearly not true, because we can't ensure things work 100% of the time. There was always going to be gaps in your coverage. And this is honestly a lesson that I have to learn day after day when I'm writing tests, is going, you know what? I'm trying too hard to test too many things and make this perfect system of tests. I need to focus on what's valuable. So the reason why we test, in my mind, is that you want to see that some things work in some circumstances for now. It's going to change and it's going to break. You're going to have to redo your tests. And I'm sorry, that's not very reassuring. It's hard to sell that when you want to convince someone why you should be spending time on testing. Yeah, well, we're just going to see that some things work sometimes, and it's only going to be good for the next 24 hours, essentially, when we'll have to run these tests again, and we'll have to run them again, and we'll have to update them and all that kind of stuff. So what's the purpose of all of this? Is not to know that the code always works all the time. I don't think that's the purpose of testing, because it's impossible to know that the code will always work and it's always going to work all the time. In my mind, the purpose of testing is to speed up software development, and you do that by not going backwards in functionality, and so you don't have the regressions. So testing helps prevent regressions from occurring, which helps you move forward, because you're not having to step backwards and fix things again. Or if you do have to step backwards and fix things, you're doing it early on. You're not doing it after it's been sitting there for a while and it's harder to find issues. And then you avoid expensive outages by catching them early. The key here is costly bugs. You're not trying to prevent all the bugs ever. You're trying to prevent the really costly ones. And the reason for that is UI testing specifically is expensive. It takes a lot of work to write your tests. It takes a lot of work to keep them maintained, and they're slow. So these are just the realities of UI testing. Maybe there's a magical tool out there that I haven't run across that is super fast and it doesn't take any maintenance and it just does all the work for you, but I haven't found it yet. So I think if you get anything, focus on these two items when you're thinking about writing UI tests. You want to speed up software development, not slow it down, and you want to prevent costly bugs. If you focus on that, then your test will always have value. Let's talk about what automated testing is good at, kind of tongue-in-cheek here. I think automated testing is really good at distracting developers from their main job, which is to write code. It's really, really good at creating false failures. I don't know how many of you have been out there and you are working on automated tests and they're breaking for some reason, and you're trying to fix the test because the test is broken. And then you realize, wait, no, the test worked fine. It's the website that's broken. Whoa. I don't know how many times it's kind of sad, honestly, that I'm surprised when the test catches an actual bug. But yeah, tests are really good at creating these failures that aren't actually failures. There's just something in the system messed up, and I'll talk about that in a minute. They're also really good at getting ignored, because, and we'll talk about this in a little bit, but people don't like failing tests, and because they create a lot of false failures, people tend to start ignoring them because they think that the test is broken instead of the code themselves. But what they're really good at is hackathoning. They make really good hackathon presentations, UI tests do, because you can set up um, this quick demo that shows that you can go to a website and log in, and it promises these hackathons show all the benefits of UI testing, and it doesn't get into any of the drawbacks or realities of how difficult it is to write UI tests. So this is what testing is sold as in my mind. It's sold as a slightly complex practice that will prevent a majority of bugs. But in reality, to me, testing is an incredibly complex practice that maybe, if you're lucky, will prevent a few bugs. Hopefully, those are the costly bugs. Now, this is a lot of downer stuff, I know. But there is hope. We're not there yet. We got to talk about why it's so difficult. And I put it in pretty text so that it's nicer for you, because I think this is not the nicest of topics. So why not have some pretty text to look at while we're talking about why testing is so difficult? Let's think about a simple test for a car. So you have this story: as a driver, when I turn the key, the engine should start. Seems very simple because you're inserting the key, you're turning it, and you're checking that the engine should start. But there's a lot that has to happen for that engine to start. You have to have timing belts work. You have to have sensors work. You have to have your fuel lines. You have to have gas in the car. You have to have your spark plugs working. You have to have a battery that's charged up. You have to have a lot of stuff in place in order to run this test. What if the car's already running? You have to make sure that the car's not already running, because if you try to turn on the car when the car is already running, that's going to cause some issues. What if you're not using the right key? All this sort of stuff. So for me, a simple assertion does not necessarily mean a simple test. So just because all you're doing is asserting that the car starts doesn't mean that test isn't a lot of work to get set up. And this is how I feel how it is with UI testing. So here we have another one that's more relevant to websites. As a user, when I enter my credentials, then it should log me in. Seems very simple, because all you're testing is that you go to the login page, you enter some credentials, you hit submit, and it takes you to the right page. But in order for this to work, you have to have your database set up with the right user. You have to have an API, if it makes an API call, that knows how to get to that database. You have to have the browser working. Your display needs to be the right size. If there's third-party scripts, those need to be working. You have to have the proper HTML selectors in order to enter the username and password. What if they're running A/B tests on the login page? You got to handle that. How about if the user is already logged in? And are you even testing on the right server? What if that server has the wrong user credentials? All of this stuff goes into a simple test. And this is where all the complexity comes flying in, because you write, like going back to that hackathons thing, you write a quick test to show that the login page works. And that's great. But getting that test to run, integrated into your CI/CD process, and getting it to run on the dev's local environment, and making sure that it doesn't take too long, that's where all the complexity is. And it's all hidden under this very simple layer of, oh, I'm just testing that you can log in. So I'm going to build a checklist of why UI testing is so difficult. And we're going to start with, we're just testing too much stuff. When we write UI test, we are testing too many layers. And it's great because you have a lot of really good code coverage when you write your test. But it's so complex because there's just so much that you're testing, even in a simple test. This is a huge part of why teams set out to write UI tests and then just get hung up on how complex it is to make those tests work and run all over the place. The next thing that makes UI testing difficult is that they're slow. And the reason they're slow is that they involve browsers and loading websites. So, if it takes 2 seconds to load a website, which that's actually a fairly fast page load, especially if you're running like on a development server that doesn't have the full specs and everything, every single test is going to take 2 seconds. Well, if you're If you are running 10 tests, that's 20 seconds. How about 100? That's 200 seconds. Now to run 100 tests, you have to wait over 2 minutes, I think, if I did my math right. Yeah, over 3 minutes just to run your tests. That's not going to integrate very well with the development lifecycle, with writing code, and with running your tests often. So because of this slowness, because after like 30 seconds, maybe even 15 seconds, I found for me when I run my tests and they take longer than 20 seconds to run, I lose focus. I just have trouble sitting still waiting for the test to run anything over like 30 seconds. So I lose focus. And that means that I'm hesitant to run my tests. And when you're hesitant to run your tests, you're not going to run them as often. And so if there are times that it breaks, it's going to be later and later in the software development cycle. And there was a famous study that just showed the later in the development cycle that a bug is caught, the more costly it is. And in my experience, most test suites take between 10 to 30 minutes to run, usually about 20. And so you're not going to want to run those test suites on your local computer as you're developing, because as a developer, I know once I get code written, I want to get it pushed up and get it ready for code review and all that stuff. I don't want to sit there for 20 minutes, wait to see one of the tests fails 15 minutes in, and then it turns out it was just some flaky failure. I mentioned that tests are really good at failing. UI tests are really good at failing. This is one of those, and then I have to run the whole test suite again. And man, it's been an hour and a half. I just want to get this code up there. You know what I'm gonna do? I'm gonna push it up, and I'll let the CI/CD system take care of it. And then, it just pushes it down the road. So that's the next issue, is we're not testing often enough, because UI testing is slow, means that we're pushing off testing, means that we're not testing as much as we should be. It's the next issue. This list is going to grow. The next issue with UI tests specifically is that they're loosely coupled to the HTML. With unit testing, you can really get your tests really close to the function itself. And so when that function changes and you need to update the UI tests, the unit test, it kind of goes hand in hand. But people can change the HTML of a website without having any clue that the UI test exists. If you're talking about an admin who manages the content of a website, so they don't even mess with the code, they just go into some website interface and they make changes there. They can make changes and have no clue that there's UI tests at all. And so this just creates a lot of chaos in the system and a lot of maintenance nightmares, because you run your tests, they're working perfectly, you run them a second time, and now they're completely broken, and you have no idea why. Well, it turns out somebody in some other team made some change that not thinking about the test, and now you have to figure out not just like why the test is broken, but what change was made. What was the thing that changed? Because that's one of the biggest issues with trying to fix tests, is you're just trying to figure out, why did this test work before and why does it not work now when I didn't change the test itself? And then the question is, whose job is it to fix it? Is it the developer's job who changed it, or the admin's job who changed it? Or is it the QA engineer's job who is technically maintaining the test? And yeah, it's a really difficult problem. It's a really difficult team dynamic problem that we all have to address. So there we go. Item number 3, tests are loosely coupled to the code. Let's keep going. This is fun. UI tests have the unique issue that you have to test all the environments in the world. So maybe you don't have to, but if you really wanted some really good coverage, you would want to test on the 4 major browsers: Chrome, Edge, Firefox, Safari, plus maybe a couple versions of those browsers. It depends. Maybe Safari, you want to do a couple versions. Edge, maybe do a couple versions. Plus the 4 main operating systems of Windows, OS X, Android, and iOS, plus maybe a couple versions in there. And the 4 main screen sizes. So you got your phone, tablet, monitor, like laptop monitor, and then like large screen monitor. You want to test on those different variations. Um, so just those things combined means that you have one test you need to run in 64 different variations. Now, 100 test is what, 6,400 variations. This is a lot. And now you have a test that runs in 99% and then it breaks in this one environment, and you have to figure out why in the world does this test not work in this one environment. And if it's on mobile and if it's on a specific phone, then you have to get that phone set up and get it all configured in your local environment so that you can actually reproduce the issue. There's just a lot of work to get test coverage in all these different environments, because and then you have to deal with responsive websites as well. So the selector that you use for desktop may be different on mobile, and now you have to write a test that manages that and can handle that. It's super complex trying to do all this stuff. So yeah, that's the next item, hundreds of variations to test on. Let's keep going. How about some integration woes? So you get your test running, say you have your simple login test. Now you want to say, well, I don't want this login test just to run on my local computer. I want it integrated so that when a developer pushes up code, it runs the test for me. And it makes sure that the login page isn't broken, but also that they didn't break the login test. The problem is, in order to get that integrated into the build system, you have to know how to run the test in that system. So you have to get it set up. You have your local development environment for writing these tests that probably doesn't match what get the CI/CD services. You have to figure out how to get there. You may not even have access to that. Assuming you have access to add all that, you have to keep the data consistent between your local server and your dev server, because you want to run the test locally so that you can debug it and write new tests. And you need to run it on the dev server so that it's integrated into the CI/CD process. So what happens when those are different databases? And so you've got your user that you use to log in that's on your local machine, but it's not on the dev server, or vice versa. And then what happens when somebody on the dev server accidentally changes that user? Now the test is broken and you have to figure out why it's broken. And then also when you're on this dev server, say it's a server that has been up and running for a couple months, if you're doing that, then every time you run tests on that server, those tests can modify the data. And say you run multiple tests at the same time on the same server, they can conflict with each other. And then you've got an issue where the tests are failing because of some race condition in your test. It's a mess. And then on top of that, you also need to manage the browser inconsistencies between your local machine. Maybe it's, I hit escape. I shouldn't have done that. Get back there. You have, your browser on your local machine isn't the same browser that's running on the CI/CD server. So you have this issue of well, the test works on my machine. Okay, now I need to debug a test that's running on this server that I don't really have full access to. How am I going to manage this? Why in the world is it breaking on the server but not on my local machine? This is so frustrating. Yes, I'm speaking from a lot of experience here because I've dealt with this a lot. So let's just add to our list that CI/CD systems are very complex. Speaking of complex and unique, tech stacks are unique. So you think of a tech stack as your front end language, and it's usually JavaScript, and the framework that you're writing it in, say React or Vue. But you also have your back end language that you're trying to that runs the API. You have your specific database, your specific CI/CD system, your specific third-party testing system. So I'm thinking of something like Sauce Labs or Browser Stack for running tests on. The deployment environment, where are you deploying this to? How are the URLs set up? So in order to get your tests integrated to this tech stack, your test stack is like this very unique thing for the company and the development environment itself. And there's a very low chance that there's a tutorial out there for your specific tech stack. There's tutorials out there for parts of your tech stack, but half the battle is just getting your tool, the testing tool that you have, working with your very specific test stack. And this specifically goes to like CI/CD systems and the front end framework that you're using and the database that you're using. So you're kind of left on your own in this regard because it's just impossible to write documentation for that many variations out there. So let's add that to the list. Each tech stack is different. We're going to keep going. But say like you realize all this, and so you're going, okay, this is too complex. I'm testing too many things. It's just too much variation going on. What I want to do is simplify my tests. What I'm going to like mock out my database, or maybe mock out the API responses, or use API calls to set up user data. This is great. It's really good for helping maintain, but it's not easy. It's tricky to implement mocking because especially when you get to like server-side data and server-side pages that just get generated on the server and then served up. Say you have like a blog page that you're trying to test. You're trying to ensure that it lists out all the top 5 blog posts for the blog homepage. Well, chances are that's not an API call that's happening in the browser. That's just a page load. How are you going to get the test in between the page load, the server and the page load? There's ways to do it, but it's really complex and really tricky to get going. And then to add on getting that integrated into a CI/CD system, it's just very complex. So you're trying to simplify one problem, and you're just creating a whole bunch of more problems there. And along with that, we feel very uncomfortable when we're going into this space because, we're looking at our job as a front-end dev. I don't really know much about the API except how to make calls to it and how to get calls back. As a QA engineer, you may not know much about how the database is set up or how to make SQL queries. I actually know a lot of QA engineers who know a lot about SQL queries, so maybe I'll take that back. But it's outside of our main job role, and a lot of the times we're left to solve this problem on our own, and we don't really want to bother the database engineers or the API engineers. We don't want to interfere with them, so we kind of sit back, try and figure things out on our own about how to get this all set up. And we're also like unsure of what we even want and what's possible. And so we just get very uncomfortable. And so what happens is that we just don't know enough to get this mocking in place, and we're a bit scared to ask. To be honest, I feel scared to ask sometimes for help about this kind of stuff because I don't want to bother people with something that I'm just kind of, most of the time I'm just kind of like messing around and saying, oh, what if I try this? What if I try this and maybe this will help? But I'm not actually sure that it's going to work. So I don't want to waste people's time on something that I'm not sure is going to work. We got a lot to get through, so I got to keep moving. How about the fact that even if you do get it set up, mocking isn't perfect. You either have tests that don't prove anything because they're totally mocked out, or you have tests that are always breaking. How about mocking out third-party services? You don't want to completely like override what a third-party service does because that's a huge integration pain and a huge integration risk is when a third-party service changes something, it can break the functionality of your website. You want to test that. And if you have it mocked out, then that change isn't going to affect your test, and your test is going to pass, but it's going to break. So every single time that you add some level of mocking, it reduces what your test covers. And basically when you mock these services and everything, it just means that your test is less functional. It's covering less. And that's a balance to strike, but it's a difficult balance. Next up on what makes UI testing difficult is that knowing how to code doesn't mean you know what to test. And I say this hopefully humbly as a front-end developer. I can write tests and I have a decent idea of what to test, but I'm never going to be as good as somebody who's been doing this as their career because they've learned these lessons that I just haven't learned. On the other hand, they've been focused so much on what to test and how to have a good QA discipline, that they just haven't had time to know how to write the specific code, how to make API calls and all that kind of stuff. And so the truth is, you need both to be successful. You need to know how to code to write your test to make it work, and you need to know what to test. And honestly, that combination is a bit of a unicorn. And then there's also, in my experience, if you know enough coding to write tests that are really good, there's a big pressure for you just to become a coder and to become a developer instead of kind of that SDET role. With unit testing, this isn't so much of a problem. The developer is testing their own code. They're very specific with the function, and they can kind of figure that out. But with UI testing, it's just such a complex problem to focus on, and you need to know, okay, what are the key things that I need to test on and to validate. And it's just difficult to have both of those abilities because we're not unicorns. So there you go. We're not unicorns. Next up is team disconnects. This is a huge issue where you get put in charge of testing or some sort of testing effort, but you don't really have the authority to enforce it or even integrate testing into the developer workflow. You're told to be in charge of testing, but you can't actually make people test because that's not part of your role. Some important parts of testing is the ability to purchase tools to make sure that you have the right tools for the job, integrate those tools into the software development lifecycle, and have like DevOps help you with that. Shift the culture around testing so that testing is a priority, and we'll talk about this in just a second. And then even the ability to hire more people to help out. So you get put in charge of this, but you don't get any authority to actually make it happen. That's difficult. And I think that's because tests, a lot of times UI tests are treated as this nice to have. And that's because they're so complex. They take so much work and so much effort that, it's people want to be realistic about it. So they go, try your best, but also we know that you're limited in everything. But the issue is when they're treated as a nice to have, if the test suite that you're writing causes friction to the development process, development teams are going to start ignoring those tests because they're getting in the way of moving forward. And it's going to lead to tests that break and stay broken because the developers, they like, we're all human. We all have our strengths and our weaknesses. And I think one of the weaknesses, speaking as a developer myself, is that when something is causing friction, you just unconsciously start ignoring it, and you unconsciously make reasons why you can ignore it. And this just means that your tests break and then they don't get fixed, and QA engineers are always having to play catch up, and they're always moving forward. The developers are moving forward, and they end up breaking more tests because now they're not running the test because the tests are broken. And it just creates this terrible cycle. Okay, I had to split it into two because it's getting too long of a list. But basically, team dynamics prevent sustainability. Man, we still got a lot to go through. More reasons why UI testing is difficult is that we get sold tools that are sure to solve all the problems. But the problem with these tools, these testing tools, is they're either too advanced for most people to use, or they're too basic to scale up and be useful on a large scale. So yeah, they make a great presentation and they make a good hackathon, but when you try to scale it up and make it reusable and all that stuff, it just falls apart. So, we try to use tools to fix the issues, but it just instead hides the issues. How about some edge cases? Ever deal with edge cases? Time zones, leap days, turning on experiments for functionality, specific user data that occurs, having specific cookies, certain third-party scripts that sometimes load and sometimes don't, all your different browser edge cases. So writing tests for edge cases is super difficult in UI testing because you have to get so many little details set up, and sometimes you don't have access to get that detail set up, and sometimes you have access but it's too late, and you have to have the data just right. Edge cases are a pain. Along with that, you're dealing with flaky failures because of these edge cases. And oh man, debugging a flaky failure is just impossible. because you're trying to fix the problem. Actually, you're just trying to figure out what the problem is. And so you take out this piece of code, or you do something to try and see, okay, is it this piece of code? And then it passes, and then you run it again and it fails again. And these tests, again, going back to UI tests, are slow. They're slow. So you're taking 2 minutes to run the test, and then it fails, and then you have to fix it. And it takes a long time. And I was going to give a story here, but it's a long story. Essentially, this summer I had to deal with like the worst bug that ever occurred, and it took me like a week and a half just to pinpoint the issue because of a whole series of cascading issues. And it turned out that it was a one-line fix for the code, and I felt really disappointed because here I am spending a week and a half to fix this test issue. I'm submitting one line of code, and I'm like, yeah, that's what I did for a week and a half. I did this one line of code, and it wasn't even real code. It was just adding a URL to a JSON file. That was difficult. Okay, I think that's enough for our list of what makes UI testing so difficult. All of that makes it so difficult. Is there really hope? Looking at that whole list, I think so. I think we just need to realize a few things before we can really have hope. First off is that you can't solve this problem all on your own. And this is specifically for the QA engineers out there and the front end devs out there, even the project managers out there, not the CTOs out there. You can solve this. You have the power to solve this. You are the CTO. That's your job. Everybody else, what happens is that you're trying to make these tests work. You're trying to get them integrated, but you're trying to steer this giant battleship with a paddle. And even if there was nobody at the controls of the battleship, that's going to be difficult to do. But you have somebody at the controls who has their own idea of where to go, and they've got all the engine power to go in that direction. And then you're there with your little paddle trying to steer it. It's just never going to work. It's never going to work trying to steer a battleship with a paddle. Just a quick story. I was at a job, and I was working on building out a test framework for the development teams to use, and it was going well. We were struggling with a few integration issues, but things were chugging along. We had a new CTO come in and totally prioritized automated testing over manual testing. And all of a sudden we had, a dozen QA engineers go, hey, we need to use your framework and we need to use it today. And we were just like, oh, well, it's not ready to use today. We're still trying to figure out all this stuff. And so, here we are trying to be smart and intelligent about holding off on releasing this until it's really ready for teams. And then all of a sudden the CTO comes in and says, nope, we're going to use this. Actually, the CTO didn't even say that. The CTO just said, teams, you need to automate your testing. They saw this framework that we were building, and it just really stirred up the water a lot in our project timeline, and we had to refocus everything. And that was just one example of you can have your plan, but be ready for it to be totally wiped off the map. Next up is that it's tough to speak up, and this goes back to the complexities and trying to get this integrated and trying to create a testing discipline within the software development mindset. And the problem with being a lot of times that I see in myself, I've experienced myself, is that you're still unsure about this whole automation thing. You're still inexperienced in it. You can never get experienced enough in automation. Maybe you don't have all the connections you need to various important people. So like the DevOps team, maybe you need them to help you get set up with this CI/CD stuff and get it integrated, but maybe you're new to the job. You've only been there for 3 months. You either don't know who to talk to, or you're afraid of taking too much time. And then the other thing is, if you speak up, if you say, hey, developer, you broke my test and you didn't even run the test. This is supposed to be part of the development lifecycle, and you just ignored it. If you speak up on that, then it's your job on the line. If a manager comes in and says, nah, the developer's right. You need to get off their case because you're supposed to be in charge of testing. They're not in charge of it. So yeah, you can get into it's your job and it's your paycheck. So politics do exist inside of companies, and it's very difficult to handle, to work through that sometimes. Along with that, it's really easy to fall into this endless cycle of, let's create a proof of concept for this. Let's create a proof of concept for this idea. And it gets the system working. And your hope is like, okay, once I create this proof of concept, people are going to get super excited and they're going to jump on and they're going to help me out and all this kind of stuff. But what happens is they get excited and then they get back to their job. If you're lucky with testing, you're able to get like 50 to 100 tests in place, but they're flaky, they're slow, and then they don't really test what needs to be tested. And all those underlying difficulties are still there. So it's an easy trap to fall into of thinking that, okay, I just need to add one more test and then it's going to really take off. No, you got to fix the underlying system. And a lot of that has to do with team dynamics. And that's really difficult. So I still think there is hope because we've identified a lot of the root issues. Now we can look at addressing them. And I think what we got to do is focus on one of two things. You either go really big or you go really small. So really big is, I'm doing this as a career move to improve QA discipline. I may burn up along the way and just, that's it for the job. But you've got to put your job on the line if you want to make these huge team dynamic changes and to really be honest about the difficulties in place and be honest about what you need. That's going big. You don't have to do that. You can just do it for yourself to improve your ability to deliver as a QA engineer or as a developer. You can stay small. There's nothing wrong with staying small and using testing for what you want. So yeah, accept the risk of going big and do it, or manage your expectations. Again, you don't have to risk your career to do this. You can focus on what helps you get your job done. And that's perfectly fine. But let's talk about going big. Here's what I would think you need to do if you want to go big. Focus on the money. Focus on what makes money. What makes the company money. And the reason for that is that's where the value lives. If your test can focus on what makes the company money, so say the checkout page, if we can focus our test on the checkout page so that the checkout page never breaks, let's ignore the about page, let's ignore the blog stuff. That's important stuff, but it's not what makes the company the most money. So if the test can protect that value, then the tests themselves have value. Tests on their own don't really have a lot of value. They're not functional code. They're testing functional code. So the value that they provide is only, it's limited by the value of the code that they're testing. So if you focus on the money, they have a lot of value. To get to that, you need to talk to stakeholders, talk to the people who are kind of in charge of these big money makers, even if you don't know them. And this is where the kind of that career risk and that being brave comes in, is that you need to go out there and you need to have candid conversations with people who aren't on your team, who are on a different area of the company, to know what is it that keeps them up at night. What is it that they're afraid of breaking that you can help with? Because you have a valuable skill. Automation is an insanely valuable skill if it's applied right. Also, you got to gain some power, and don't play politics. I hate politics, but there's certain powers you got to have in order to change team culture. Because if you're going to change team culture to make testing be this more important thing, to maybe do shift left testing or something like that, it's going to conflict with other people's visions. Not necessarily in a bad way, but there's just going to be friction there. And so you need to have enough standing in your company to have authority to try your ideas. This goes back to the ability to purchase tools, integrate those tools, get like DevOps people to help you integrate those tools, shift the culture around testing so that testing is a priority for developers so that they don't just ignore the tests because they're getting in the way. And then, the ability to hire and possibly fire is also really important, but that's really difficult. That's kind of getting to the QA manager space. But yeah, you're going to have some level of authority and some level of autonomy in this role if you're going to do this. If you have no chance at gaining this power, stay small. Just yeah, it's going to be so frustrating to try and make these changes and just get steamrolled by certain people. That's going to be entirely frustrating. Finally, if you can use analytics or logging to identify issues that aren't covered by tests, it's kind of a shortcut to providing value. Say you have that checkout page, instead of, that's complex to get a checkout page tested. What if we just look at the analytics and say, okay, X amount of users hit this checkout page today. We should expect about the same number of users to get there tomorrow. Let's keep an eye on these analytics, and if those have some big discrepancy, then we can get a really early clue at well, maybe not early, but we can get a big clue as, oh, maybe something's wrong with the checkout page that we're not aware of. So if you can use analytics or logging instead of writing tests, that's perfectly valid to do. And again, that's all big stuff. But honestly, don't listen to me. I've never done this. I've never gone big. I've thought about it a lot, but it's risky. So yeah, take my advice with a grain of salt there. Now let's talk about going small. And I'm going to go again. There's nothing wrong with this. And this is honestly the best choice for probably 90% of us out there, is just stay small with your testing. First way to do that is let go of grand aspirations. You're not going to cover 100% of your website. You're not going to cover 50% of the website because you're talking about all the variations that you need to cover. And there's going to be a lot of cultural blocks in your way of making this testing work. Focus on your own pain. Be selfish with it. Identify what is difficult about your job, what takes a lot of time in your job, and solve for those. Focus on automated testing to improve your own productivity, not on catching bugs outside of your responsibilities. So if your responsibility is testing the login page, focus on the login page. Make those tests as good as they can be. Get them integrated as much as you can be. Don't start going off into other people's areas, because you're just creating more work for yourself and you don't know that they're actually going to find value in it. And again, you're getting back into that team culture shifts, and trying to change team culture is just huge. It's such a huge problem, huge task to do. Along with that, don't be a salesperson. Don't try and sell testing to others, because if they're interested and they'll reach out to you. You can share your experience, you can share what works, but it's not your job to convince them that they need testing. They need to come to it on their own if you're staying small. Now, if you're trying to change culture, yes, it is your job to sell testing, but staying small, it's not your job. And if you do convince them, now you're just creating more work for you outside of your own job role. And you probably don't have the time to handle all that while also making sure that your test suite is up to date. It's okay to say no. It's totally okay to say no, especially when you're staying small. Because we're staying small, we can now simplify the problem. So we can use tools like Storybook, which I'll show in just a second, or component testing or component libraries to really circumvent the need for external systems and external teams. So I'll show you Storybook real quick. It's kind of, it's a way of building these demo libraries. So I'll show you real quick. This is the Grommet demo library, but we're looking at the accordion here, and you've got just an accordion. That's it. No integration with third parties, none of that stuff. All your testing is that when I click this, it shows. When I click it again, it hides. It simplifies things just amazingly, and you don't have to worry about data. All the data is kind of already there. Yeah, so take a look at tools like Storybook or other component testing, or not component testing, component libraries, to simplify your problem and get rid of all the third party and all the external cruft that makes testing difficult. And yeah, it's not going to cover as much. And yeah, you're not going to have that full end-to-end testing, but you are going to have some value. It's going to be valuable to you. And that's what we're looking at when we're staying small. To conclude all of this right around time, UI testing is very difficult. And I think that's just teams, they see demos and they hear all these great stories, and then they start trying to implement it themselves. And it's 6 months down the line, and they're still struggling to have tests that are valuable. And management comes in and they look at this and like, we spent 6 months on this. We have like 10 tests and they're breaking all the time. I think we just got to let go of this dream. And because you have these expectations that it's not difficult, that it's just slightly complex. And it goes back to, it's just very complex, and it provides, maybe catches a couple bugs. Go big or go small. Make a decision. Which one are you going to do? Nothing wrong with going small. Totally awesome if you're willing to really focus on going big. And then you want to focus on what's valuable. And that's really, really key to making UI tests not get caught up in a lot of the pain of UI tests. Focus on what's valuable, and that's either what's valuable to the company or what's valuable to you. That's really what I would focus on here is, when you write a test, don't just write a test to write a test. Write a test because it brings value, because tests are a lot of work. UI tests are a lot of work. They're tough to maintain, that whole list and all of that. So we're just a little bit over time, but I'd love to have questions and thoughts in the chat. We already got one from Thomas. Says, what is considered a costly bug? In my mind, it's so you have your company or the website goes back to what earns the website money or what earns the company money. If it's that checkout page, if that checkout page, say a third-party integration with a payment provider breaks, that's really costly, because if you have a semi-successful business like an e-commerce business that earns its living off of people buying their stuff, and they can no longer buy their stuff, like that could easily lose $100,000 in a day just on lost sales. So if you can have automation that prevented that loss of money, that loss of sales, then you've just basically saved the company $100,000, or $500,000, or some really large number. And now you can take that and go, hey, I saved the money, or I saved the company this amount of money just through my automation. You should keep letting me write automation, because that's what it's what brings the company value. And if you help save value, because tests aren't going to provide, they're not going to give or earn money on their own. They're just going to save money. So that's what I would focus on, is like, those costly bugs. Gary asks, pretend you were a CTO. Everything would be perfect. What would your general strategy be? Yeah, that's difficult. I've never pretended to be CTO ever, because it's just a far off dream. My strategy around testing, UI testing specifically, is again based around how can we bring value in these UI tests. And then I also would focus on, there's a story that I read a while back called The Black Triangle, and it's about this game development team that spent about a month trying to make a black triangle appear on the screen. And they could have made that black triangle appear on the screen within a day, but what they were really trying to do is create this system, this fully integrated system that allows for the full build out of that simple little task. And I think we need to focus on that in testing, is let's get a basic test and have that basic test be fully integrated into the development process, have full reporting to the stakeholders to show, hey, this test is passing, and you get information about this test passing, is not flaky, is not going to break all the time. And if it did break, like, development would focus on getting it fixed. So, it's a simple test, and we want to feel like in order for our test suite to have value, it needs to have a lot of tests. No, in order for it to have value, it needs to be fully integrated into the full development lifecycle. So that's kind of what I would focus on with automation at first, is get it fully integrated, get that black triangle program fully integrated, and then go from there. What I see happen too often is we just want to add tests and add coverage and add tests and add coverage, when the tests that you already have are breaking all the time because they're flaky. And so what's the purpose of adding new tests if their tests are already being ignored? And this happened, to me, is I was asked to add new tests. I'm like, but the tests that we already have are getting ignored. They're not, they're breaking all the time. And because they're breaking, people don't think that it's the code that's breaking. They think it's just the test that's breaking. So it was just a backwards mentality of focusing on writing tests versus on focusing on making those tests actually useful. Any other questions or thoughts? Okay. What do you say on average is a reasonable UI test coverage percentage? I mean, it depends on what you're considering covered. Are you talking about testing all the 4 major browsers? Are you talking about testing all the top 100 devices? That's part of code coverage. If you need to make sure your website works on all those browsers or all those devices and all those variations. Are you talking about, even just covering the responsive design, mobile and desktop? So it's a difficult to nail down. If you think about it from like the full breadth, maybe 20% at most is like really good coverage. There's the 80-20 rule that says basically 80% of the value comes from 20% of the content, or like 80% for companies, 80% of their revenue comes from 20% of their customers. Think about that from the testing perspective. 80% of the costly bugs out there is going to come from about 20% of the website. So if you get really good coverage for 20% of the website that provides that 80% value, then you're, versus covering 80% of the website that only provides 20% of the value, it's so much better to focus on that small slice that provides most of the value for the website. Cover the checkout page, cover the login page, cover the upgrade page, things that generate that value to the company. So I actually did a recent talk on my YouTube channel. If you're interested, you can go to YouTube, Front End Testing with Kevin. 100% code coverage. And it talks about code coverage. This is more kind of like unit testing stuff. But you can kind of think of it the same with UI testing. So yeah, I meant to plug that. I've got this YouTube channel. I've been trying to add more videos as we go. I have a new one coming out on the great divide between front-end developers. I really enjoyed it. Hopefully that'll be out there. Another question, you mentioned an example of if checkout breaks. What do you think about UI testing suites being used to sort of monitor the status of a production checkout page? I think it's a great idea. It's a little bit difficult with a checkout page in production because you are dealing with like live transactions. And so it's difficult to mock that out. You really don't want to mock it out because you're trying to test production, but you also have to handle all of the nitty-gritty details of that. But UI tests are utility. They are a utility. There's no one specific way to use them that's right. The way to use them is what provides you value. If it provides you value to have this test, this UI test that runs every 5 minutes, checks that you can run a login or run a checkout, that's super valuable. There's absolutely no reason why you shouldn't use it that way. as long as you can make it work. So yeah, I'm totally for that as an idea. And honestly, this is where those third-party tools that are like the scripting tools, or there's a lot of testing tools out there that are a little bit basic and a little bit more like click and record your actions and stuff. Do that. And you can use those for testing like prototype pages. Say you want like a quick and dirty test, just to kind of as a smoke test, to make sure that this prototype is mostly working. Totally do that. There's nothing wrong with writing a test that you throw away a week later, so long as it doesn't take a week to write that test. If it takes you 30 minutes to write that test that you run 50 times and then you throw it away, go for it. That's so useful to have that. Don't be afraid to throw away tests, and don't be afraid to write tests in a really sloppy way, because you know you're going to throw them away, or you know you're going to replace them. Okay, last question is, will this session be on my YouTube? Not this specific session, but I am thinking of basically recording it again and posting it to YouTube. Pretty sure I'm going to do that, because this is something that I'm really passionate about. And I just might make some tweaks here or there to make it a little bit better. We can always use improvement, but you should get a link through Codementor with this recording. I'll go ahead and stop sharing. So let me double check real quick before heading out. Send a quick little message to everyone. Oops. Just double check that everything is good to go. Okay, so yeah, it should be up on Codementor in about a week, and I'll try and get it recorded as well for the YouTube channel. And thank you all for coming out and listening and sticking around. It was a lot of content that I threw at you. Actually, I will share a link here if you want, and I'm just going to take out the first part of that. But this issues page, I was working on some tests, and I just went, this isn't possible. This is so insane that I'm trying to write these UI tests. And so I'm not actually sharing my screen. Let's do that real quick, and then I'll let you go. This GIST, it's just what makes it complicated. And it's basically all the things that I talked about here with a little bit more detail. I didn't cover like what companies need, kind of how I was thinking about some ideas here. And then this is the full presentation for it. So if you're interested, I sent that link in chat if you want to check it out and kind of look at the different parts of it. Again, thanks so much for showing up, and hope to hear from you. You can email me, reach out to me, however you want. Have a great one. I'll stick around for a few more minutes in here, but you're free to go.